Here we are going to have an example where we have used the polar coordinates r and theta instead of the Cartesian coordinates x and y. In some particular cases, the use of polar coordinates is more convenient than that of the Cartesian coordinates. So let us say which form the Cauchy-Riemann equations take in polar coordinates. We know the coordinate transformations. X equals r cos theta and y equals r sin theta. Now we have to find all the four partial derivatives u sub r, u sub theta, v sub r and v sub theta. Since u and v will become the functions of r and theta, so we have to use the chain rule of partial derivatives to find these first ordered partial derivatives. Let's have the detailed calculation for one of them. Initially, both the functions u and v are functions of x and y. Now, in order to get u sub r, that is, the partial derivative of u with respect to r, we are going to apply the chain rule of partial derivatives. This derivative can be written in this form. And this one can be written as u sub y Now to replace these values, since x is given as r cos theta, so if we differentiate x with respect to r, then cos theta will remain as constant coefficient, and for r we will get only 1. So partial derivative of f with respect to r is cos theta. And similarly, from this one we get the partial derivative of y with respect to r is only sin theta. In the similar way, we will find u sub theta, v sub r and v sub theta. Now, from the Cauchy-Riemann equations in Cartesian coordinate system, we know that u sub x equals v sub y and u sub y equals minus v sub x. So we replaced these values here. We replace v sub x equals negative of u sub y and v sub y equals u sub x, and also similar replacement have been occurred here. And finally we get this form, that is v sub r equals negative of u sub theta over r and v sub theta equals r u sub r. So these two equations are the Cauchy-Riemann equations in polar coordinates. Now at a particular point z naught equals r naught theta naught, the Cauchy-Riemann equations take this form. We also have a theorem which states the sufficient condition for the differentiability of a complex function. If the complex function is defined in this way, that is in the polar form, then the conditions are this. The theorem is as similar as It was for the function in Cartesian form. We also have the formula for finding the derivative of f, which is e to the power minus I theta times u sub r plus I v sub r. At a particular point, z naught equals r naught theta naught, it takes this form. Let's come to the example. It is given that f of z equals 1 over z is differentiable for all z except the origin. Now we are asked to verify the Cauchy-Riemann equations for this function, and also we have to show that the derivative of f is equals negative of 1 over z square for all z belongs to C except 0. Although it is not necessary to use the polar coordinates in this problem, but here we have used it to show the procedure of calculations for a function in polar coordinates. Since f of z is not given in terms of x and y, so we are directly using z equals r e to the power I theta. Now 1 over z can be written in this form, that is e to the power minus I theta over r. Here e to the power minus I theta can be written as cos theta minus I sin theta by following Euler's theorem. And then here we get u equals cos theta over r and v equals negative of sin theta over r. Here both u and v are functions of r and theta, so we can easily calculate all the 4 partial derivatives. U sub r, that is partial derivative of u with respect to r, can be calculated as we are differentiating only 1 over r and keeping the cos theta as constant. So differentiating 1 over r provides negative of 1 over r square and the cos theta is constant. Similar fashion will be followed for the other partial derivatives. So we see that the Cauchy-Riemann equations are satisfied here. Now we will find the derivative of f, which will follow this formula. We are just to replace the values of u sub r and v sub r, which we have already found. After some simplification, we get f prime z equals negative of 1 over z square, which was asked to show.